This is an LED strip from Lepro. Here's the box. No power supply included. I think I didn't buy one because I'm just gonna cut this and create my own connector. The power supply shouldn't matter that much as long as it's enough to light up the semiconductors, to heat up, to facilitate the movement of the electrons in the semiconductors. I have a power supply right here. It's 10 volts at 5 milliamps. It should light it up very dimly. I don't know what the minimum wattage is, but it should be enough. So I stripped the female connector with the power supply that was not included because I didn't want it. This is an alternative power supply. So the power wattage is enough to light it up. So my intentions are to, oh, it looks like Christmas already, to create a variable resistor. Use a variable resistor to control the power going into the LED strip to control the intensity of the light. So things to test are to see what's the minimum power. I don't want to mess around with maximum power, but minimum power is important. Yeah. So I got one more good one that's untouched. It came with two. I was expecting just one, but that's good. So here's a little look at the LEDs closely. So you can see the different cables running underneath the paper covers. I'm not sure what these numbers. Not exactly. Oh, these numbers mean the units. 19, 20, 21. Resistor R7. Interesting. Yeah. So right now the power is 5 watts. The recommended one that comes with it in other packages is around 1.2 times. This 1.5. I don't want to do the math. That's like 10, 15 amps, 20 amps. About 20 amps. Yeah. There's two ways of controlling I can think of controlling this LED strip. One is to use Arduino to control it digitally using this USB-C channel, right? And then I can connect it to this board. I also have analog, just mini breadboards. Can put in my own components from older kits, and I can create my own. What would you call it? A switch. LED switch. Let's call it a switchboard. Yeah, a power switchboard. Input for power, and some components to control the power output and the channels. So basically, I can redirect the flow of the current. I can make it go left or go right. Turn it off. Adjust the amount of power going into both channels, and then using combination of the switch and the controller, I can control the power going into either. And of course, if I need to, I'll put in a resistance in between to help prevent overlighting. Because this is actually kind of bright. I'm planning to do this in my room. I know I'm gonna make sure not to take off the tape because I want to put it underneath some of my what do you call it? The stands on my table. It's for decoration. I'm gonna use the board because I don't want to use up an Arduino board. I just want to use it as an experiment, just to practice, so I remember how to use Arduino. It's been a while, and then this is the start of the show. But I'm gonna put it on my table. It's gonna have like a connector. This, or I'll just take the cables and just put it in, solder it, make sure it's very stiff. I have header pins. Yeah. Bring headers, connect to board, bring resistors, bring a switch, bring button. I might make it the board. I might design the board at home, and then yeah. So I gotta. Actually, let's do it right now. I'll design the board right now. Here we go. This is my diagram. I did a little extra just to exercise. I don't think I've ever worked with doing calculations for variable resistors, but basically this is, hold on. This is my input, this is the output, this is ground. Input 12 volts. Here's a switch, Here's a button just to turn it on. Just press it, open up a channel to turn on the LEDs. The variable resistor, so it has one input and has two outputs. So both outputs are related. So as one output goes down, the other outputs go up, and the combination of the two outputs add up to whatever the input is, approximately. Just some losses, but it's negligible. So the LED strip is, so one of the channels is used to power the LED strips, and the other one is just connects to ground, and this one just becomes 0. Initially it's whatever this is. So I think this is the calculations for it. I've never done it before, but this is based on what I remember for electromagnetism and electrical engineering crash courses. I use this relation. And I use this relation, and this relation to create this one.